Today we're going to look at section 8.5, which is about properties of logarithms. So in the past couple sections, past couple days, one section, we introduced what a logarithm is. That is the inverse of an exponential, and we looked at how to graph them, and we looked at how logs and exponentials can cancel each other, and we can move back and forth between them. Today what we're going to look at is some ways that we can simplify log expressions in the same type of way that we simplified exponential expressions. So what I want to do is review our properties of exponents, because since logs and exponentials are related, that means their properties should be related. So if we can make that connection, hopefully it'll be easier for you to remember these properties instead of trying to feel like you're learning something totally new. So properties of exponents. If I have x squared times x to the third, I get x to the fifth. So multiplying becomes adding. Right? We're multiplying our bases, and then we added our exponents. Okay? Let's say I had x squared cubed. What do I get?
Multiplying.
Multiply them. Get x to the sixth. So then here, a power becomes a multiplication. Okay, it was a power to a power, and we simplified that by multiplying them. And then last one here, let's say I have x to the 8th over x to the third. I get x to the fifth. So then here, division became a subtraction for our exponents. So these three properties of exponents that we learned quite a while ago are going to show up in these properties of logs. But since logs and exponentials are inverses of each other, they're going to show up kind of backwards. So our first property is our product. And it says that if we have a log, and inside of that log we are multiplying two things together. Okay, so if I have a multiplication, it's going to separate to become an addition. So multiplication becomes addition. Just like we said before with exponents, our multiplication became addition. For a quotient, I have a division becomes a subtraction. Just like with exponents, if I had a division, it became a subtraction. And as our power property, here I've got something to a power, and it turns into a multiplication. So a power becomes a multiplication, just like here, a power became a multiplication. Okay? But in one case, with our exponents, when we're doing this power becomes multiplication or division becomes subtraction, we're simplifying it, we're putting stuff together, whereas in the logs, it's actually separating it out. Okay, so this is how we can take apart logs. The reason, one of the reasons why we want to take apart logs is before calculators were readily available. If I had a log of a really big number, what I would want to do is we had log tables, and it would say log base whatever of whatever. And you'd have to look up all these logs in this big table. So one thing we would need to do then was to break it down into smaller pieces to look them up in the table, or vice versa, try to put it together to be able to look it up in the table. Now calculators are readily available, so that's not as much of a big deal, but we still need these properties to be able to solve equations. They become important to us in solving log equations, which is what the next section of the book is about. So when it says expand, expand means to make as big as possible. So we want to separate this thing out so that inside of each log there's only one single number or one single variable. Okay, so that each number and each letter have their own individual log. So our order of the way that we're going to split this is first when we're splitting, we're going to take care of any division. And according to the properties that we just looked at, division is going to become subtraction. So the first thing we're going to do is separate this division into a subtraction of two separate logs. So the top gets its own log, the bottom gets its own log, and we subtract them. The base is the same for both of them, so they're both base 2. our second step in trying to separate this thing out is going to be that multiplication is going to become an addition. So anywhere that I have stuff multiplied together inside of a log, I want to separate it out with an addition. So in this first one, I have 7 times x cubed, so I want to separate those out. So I get log base 2 of 7 plus log base 2 of x cubed. So the two pieces inside of there that were a multiplication, 7 times x cubed, each get their own through addition. Log base 2 of y, that's already fine. It's already only one thing in there. It's just going to tag along. We don't need to do any more with that. Our goal is that inside of each log we will have just a single plain letter or number. So 7 is fine, y is fine, but x cubed is still too much going on in there. So our third and final property we're going to apply is that a power is going to become a multiplication. And that multiplication happens down at x cubed, that 3 is going to drop down in front and become a multiplication. And then the y part was fine. There. Okay. So in expanding problems, we're kind of unsimplifying them. We're splitting them up so that they each have their own individual log. When you are finished with the problem, after each log, there should be a plain number or a plain letter. Okay? And we're always going to take the properties in that order that's written at the top. So we'll start by separating any divisions, then we'll separate any multiplications, and then we'll take care of any powers, dropping that number down in the front as a multiplier. Okay. Let's try another one. So the order of those 3 steps, I said first we'll take care of division. This one doesn't have division, so that just means we don't do that step this time. So then we need to take care of the multiplication. So I'm going to separate the 2 and the x to the 6th. And multiplication separates with addition. And then 2 is fine because it's just a plain 2, but x to the 6th, that's too much going on in there. We want a plain number, a plain letter. So we're going to take that power and drop it down in front. So it's going to become 6 log base 5 of x. Questions? Okay, so then our next kind of problem is the exact opposite. Condensing means we want to put this back together. So our goal is here that we will have just one single log with everything inside of it. So since this is exactly the opposite of the last kind of problem, we're going to take those steps in exactly the opposite order. So the first thing that we're going to do here is take care of any multiplication, raising it up as a power. So those steps that we did last time, we're going to do them exactly backwards. So if I have any multipliers in front, I'm going to take them and bring them up as a power or an exponent. By the way, I should say you can only do this if the logs all have the same base. What are the bases of these logs? 10. There's no base written, okay? And whenever the base is not written, that's our common log with a base of 10. So they do all have the same base here. And the book and I are not going to try to fool you on this, but just to be completely honest about this process, you can only do this if the bases are the same. Just like we can only do it if the bases are the same with our exponents. If I had like x squared y cubed, I can't put those together because the bases are different. Same thing here with logs. You can't put them together if the bases are different. But I'm not going to try to fool you on that, and neither is the book. So the next thing we're going to do then is take any addition, and it will become a multiplication of the stuff inside. So anywhere that I have logs that are added together, I'm going to take them and smush them together by multiplying what's inside of them.
In the second log.
I put the two logs that are circled together by changing the addition to a multiplication. And then our final step, working backwards from the first type of the problem, is to take any subtraction and turn it into a division. Always do the first thing divided by whatever's being subtracted. So whatever has the negative on it is what's going to go to the bottom, just like negative exponents go to the bottom. Okay? So whatever has the negative there for the subtraction is going to end up in the bottom of this. Now since these are all just numbers, we can actually do this arithmetic here. Sometimes you'll have variables, sometimes you'll have numbers, but here we can actually do this arithmetic. So 2 squared is 4, times 6 is 24, divided by 3, we get 8. So if you can do arithmetic, go ahead and do it. If it's variables, then we just leave it. So practice another one of those. So the first thing we take care of is powers. Take care of multipliers, raising them up as powers. Then the second property that I said we would take care of is taking care of any addition and smushing it together as a multiplication. But we don't have any additions in this problem, so we don't take that step then. So then the only other thing we have left is a subtraction. And the subtraction will become a division. And we do whatever the subtracted one is will go to the bottom. There's a little bit of arithmetic we can do here and say that it's 49 over x to the 5th. And our goal in these ones is to get everything put together inside of just one log. Okay, so in expanding, we want everybody to have their own. And then here, we want them to all be grouped together inside of one. Questions on condensing or expanding? The calculator can only evaluate 2 kinds of logs. It can evaluate the common log, the base of 10, and it can evaluate a natural log, the base of e. So we have this formula that allows us to change the base of our logs so that we can type logs into the calculator and approximate them, even if they have different bases. This looks really overwhelming in this formula, but long story short, what this says is we can change the base to anything we want. So we could change the base to 10, we could change the base to e, we could change the base to 4 if we wanted, but it wouldn't really be helpful in terms of putting it into the calculator, but we can change the base to anything. So we're typically going to change it to a base of 10 or a base of e. I will tell you, I am actually so lazy that I change it to a base of e because then I just get to write ln 2 letters instead of log 3 letters. Really, I'm that lazy. So it doesn't matter. We can change it to whatever we want, but base of e or base of 10 are the most helpful because those are the ones the calculator can take care of. To put some words to this big messy formula, what we're going to end up doing is doing the log of the of divided by the log of the base, or I wrote the word log here. It's the same thing with ln. So you take the ln of the of divided by the ln of the base. So with some words, we use the words of and base when we have numbers in a problem like this. What we do is take the log or the ln of 7 divided by the log or the ln of 3. Okay, so you do the log or the ln of the of part divided by the log or the ln of the base number. You have to do the same thing on top and bottom. So it doesn't matter whether you use a log base 10 or a natural log, the log base e, but whatever you do the same thing for both of them. And then you'll just type this into your calculator. So when you hit the ln button, it's going to open up parentheses. 7, make sure you close those parentheses. Divide by ln, it'll open up parentheses. And again, make sure you close those. The second step, the second set of parentheses, not as crucial, but closing off after that 7, very crucial. Okay, you will get a wrong answer there, or sometimes even an error message. And it doesn't matter whether you use your log button or your ln button, just use the same button both times. Now remembering what a log is doing, okay? What a log is doing is asking the base to what power gives us this number inside. So this is asking the question of 3 to the what equals 7. Okay? And that's the answer that we're getting. 3 to the first would be 3. 3 squared would be 9, so we expect our answer to be between 1 and 2, and it is. Okay? So that's what a log is doing, is it's giving us a power. It's asking the question of 3 to the what is that number. Okay? Just to kind of remember what a log is. Logs are very mysterious to students, and so I try to keep on reemphasizing what this thing is actually doing so we can try to grasp it. So on this one, what it's asking is 4 to what power equals 8. Okay, so for the first would be 4. 4 squared would be 16. So we're going to expect it to be somewhere between there. The way we can actually find the decimal is by taking the log or the ln of 8 and dividing by the log or the ln of 4. Do not try to reduce. Okay, so a lot of students will try to reduce down and go, oh, 8 divided by 4, I can do that, that's 2, so I'll take the ln of 2. Doesn't work, okay? You can't reduce them down. You just need to type the whole thing in. The ln of 8, make sure you close those parentheses, divided by the ln of 4. And we get 1.5. Okay, so that means 4 to the power of 1.5 equals 8. Questions? All right, we have 3 more examples to look at, but they're not anything new. There's one more of each type of problem we've looked at. Something a little bit new does come up in them that I just want to make sure to emphasize. So another expanding problem. With expanding, remember we're trying to get each letter and each number all by itself. So the first thing we're going to take care of is the division. So I'm going to go log base 7 of y minus log base 7 of 3x squared. Top thing minus bottom thing. Log base 7 of y is all set, because that y is all by itself. But 3x squared, that's too much inside of there still. We want them all separated and alone. So we need to separate that out. It's 3 times x squared, so multiplication separates with addition, and this is what we need to be careful of. We're subtracting everything after the minus sign, so what we really need to do then is subtract in parentheses the separation of that. Okay? Since we were subtracting this log base 7 of 3x squared, we need to subtract the whole separation of it. And then we'll need to distribute that negative out. One more log property to take care of. The 3 is fine, the y is fine, but the x squared is too much, so we need to take that squared down. So my log base 7 of y is all good. I'm going to distribute this minus, so I'm going to have minus log base 7 of 3 and minus drop the 2 down, log base 7 of x. Now notice that in your final answer, whatever has negatives came from the bottom of the fraction. So you can kind of skip that idea of writing out the parentheses and distributing the negative if you just pay attention to whatever starts on the bottom of the fraction, the 3 and the x part, those need to have negatives on them. Okay? Just like a negative power goes to the bottom of a fraction. Okay? Because logs and exponentials are related, so our power rules should still be showing up here. Negative powers are from the bottom of fractions, so the negative logs are from the bottom of the fraction. Okay. So another condensing one. So in condensing, our first step is to take any multipliers and bring them up as exponents. Our second step is to take care of any addition and smush it together with multiplication, but we don't have any addition here. So then our final step is to take care of any subtraction, making a division. Now, like in the last problem, anything that is subtracted, anything that has a negative in front of it, belongs on the bottom of a fraction. So we're going to write log base 8 of a fraction. Anything that has a negative goes to the bottom. So the x squared goes to the top, the 5 and the y cubed go to the bottom. Okay. Any term that is negative belongs in the bottom of the fraction inside of the log. Questions on that? So then our last problem, one more change of base formula. Remember again what this is doing is saying 6 to the what equals 15. And to find that, we do our formula log or ln of the of number divided by the log or the ln of the base number. Type it into the calculator, making sure to close parentheses after each number, so after 15 and after 6, and we get about 1.51. Question? 8.5 is your assignment for tonight.